In this question, it is given that the flow rate of water from the tap of diameter 1.25 centimeter. So we can take it as diameter is 1.25 into 10 raised to minus 2 meter is 1.5 liter per minute. So we can write the value of its volume flow rate, or the value of dV divided by dt, which is equal to 1.5 into 1 liter per minute. We know that 1000 liter is nothing but 1 meter cube. So we can write 1 liter is nothing but 10 raised to minus 3 meter cube. And in a time of 60 minutes, 1 minute, so we can take it as 60 second. So this will be the value of dV by dt. The characteristic flow rate. The coefficient of viscosity of water is given as nothing but means the value of eta is given as 10 raised to minus 3, and density of water, we can take it as the density of water is nothing but 1 gram per centimeter cube, that is equal to 10 raised to 3 or 1000 kilogram per meter cube. I'm just writing all the values in SI system. So we can find out what about the value of its Reynolds number. We know the equation for its Reynolds number, which is equal to nothing but rho into V into D divided by the value of coefficient of viscosity eta. Now we can put this value over here. The value of density into the value of velocity is not given, but we know that the value of dV by dt, volume flow rate, let's say that is equal to Q, is equal to A into velocity. So we can write this velocity is equal to nothing but Q divided by A into diameter of that object divided by coefficient of viscosity. We can take it as nothing but eta. So you can write this rho into Q into D divided by this area can be written as nothing but pi into r square into density. Now we can write this r is equal to nothing but diameter divided by 2. So we can write rho into Q, the volume flow rate, into diameter of 2 divided by pi into this r can be written as d by 2. So this is r square divided by 4 into coefficient of viscosity eta. So we can cancel this d over here and d over here. So we can write this is 4 into rho into Q divided by pi d into eta is going to give the value of its Reynolds number. Now we can just substitute the value over here, that is 4 into density is 1000, and the volume flow rate is given as nothing but 1.5 into 10 raised to minus 3 divided by 60, the whole divided by pi into diameter which is given as nothing but 1.5 into 10 raised to 1.25 into 10 raised to minus 2 into the value of coefficient of viscosity. The value of coefficient of viscosity is 10 raised to minus 3. So you can just identify what we are getting. So if you are calculating the answer, you will get around 2547. So we know that this value is between 2000 and 3000. So as the value is between 2000 and 3000, we can say that this is basically representing an unstable flow. If it is less than 2000, we'll say that streamline. More than 3000, we'll go for turbulent. In between 2000 3000, we'll say that is an unstable flow.